Okay, Assalamualaikum. Next, we proceed with the Poisson distribution. So, Poisson adalah one of the special distribution. Alright, so kita baca sikit kat atas ni using your textbook, page 132. The Poisson probability distribution often provides a good model for the probability distribution of the number of Y of rare event. Okay, of rare event that occur in space, time, volume, or any other dimension. Okay, where lambda is the average value for y. So y usually we use when the situation of our variable occur in space or in time or in volume. Okay, and usually untuk Poisson kita akan gunakan value lambda as the parameter. Okay, and lambda ini adalah average of the value of y. For example, okay, it provides a good model for the probability distribution of the number y, which is automobile accidents. For example, number of automobile accidents, number of industrial accidents, or any other types of accident in a given unit of time. Okay, kita boleh kira how many number of accident in a day contohnya, ataupun number of automobile accidents in a year ataupun in a month. Okay, during the unit of time. Ada example lagi? Okay, other example of random variable with approximate Poisson distribution are the number of telephone calls. Okay, phone calls handled by a switchboard in a time interval. Ataupun the number of radioactive particles that decay in a particular time period. Ataupun the number of errors of typists makes in typing a page. Okay, dalam volume, space. Okay, and the number of automobile using a freeway access in a 10-minute interval. Okay, so ini adalah contoh-contoh the situation of the random variable when a Poisson distribution are very suitable for that situation. Okay. So the parameter for the Poisson, if you can remember, okay, we can write the y, kita punya variable, as Poisson distribution with parameternya lambda. Some of the textbook dia akan gunakan mu ataupun lambda as the parameter for Poisson, which is lambda ni actually adalah average in a given time. Okay, kita tengok contoh nanti lagi. Alright, so this is the function ataupun the PDF Poisson distribution that you need to memorize, kena hafal. Okay, it is lambda power of y multiply exponent power of negative lambda divide dengan y factorial. Okay, lambda dekat sini adalah average. And then the possible value for y untuk Poisson adalah from 0 until infinity. Okay, from 0 until infinity. Kalau sebelum ni binomial, you punya possible value y, it can be from 0 until n trials, kan? Kalau untuk Poisson, daripada 0 until infinity. And y dekat sini adalah number of unit ataupun number of event in a given time, in a unit of time. untuk Poisson. Okay, kalau tengok example 3.18 here, dia ceritakan about how to prove that this function of Poisson adalah a valid function for discrete, which is we prove using the using the properties of this summation of the probability equal to 1. So total of the probability kat sini adalah function lah, function for py. So sebab tu dia letak kat sini function of py here. Okay, summation daripada 0 until infinity because of the possible value-nya daripada 0 until infinity. Okay, so kalau tengok kat sini nak provekan this part summation of the function adalah 1. This part dia pecahkan antara this part and this part. So this part ni actually adalah the series expansion for exponent power of lambda, this part. Ini kalau you still ingat waktu you belajar calculus, ini adalah dinamakan Taylor series. Okay, Taylor series. Okay, this part actually adalah exponent power of lambda. Okay, bila multiply dengan this part, exponent of negative lambda, so you akan dapat 1. Alright. So kita tengok example of the situation from the case study, and then daripada case study tu you need to determine the variable, and then you need to determine the parameternya, which is the average, and then from there you can create the function for random variable y, and then from there also you can find the nilai probability. Okay, look at example 3.19. Suppose that a random system of police patrol is devised so that a patrol officer may visit a given bit location from 0 until infinity times per half hour period. Okay, so kita punya variable kat sini adalah number of visit. The location per, kena ada perkataan ni, per half hour period. Okay, per half hour period. Sebab variable untuk Poisson ni it shows in a interval of time ataupun space ataupun volume. Okay, in this example it is about time. Okay, number dia punya variable adalah number of visit, number of patrol officer visit the location per half hour period. So dia berkata kat sini ada information kat sini, with each location being visited an average of once per time period. Once per time period. So lambda ataupun average kat sini adalah 1. Okay. So we know that y adalah Poisson. Kenapa Poisson? Sebab dekat sini half hour period ni. Okay, situation here within the period of time. Okay, so Poisson 1. Parameter untuk lambda here is 1. Parameter for this Poisson distribution is 1. So we can create the function of y ataupun py, which is the the PDF for Poisson distribution. Okay, which is 1 power of lambda e power of negative lambda divide dengan y factorial for y from 0 until infinity. Okay, so kena ada possible value for y. Once you write down the PDF for the random variable. So this is the function for our example here. Okay, soalannya ditanya, calculate the probability that the patrol officer will miss a given location during half an hour period. Okay, so nak cari probability of y equal to 0. This part, y equal to 0. Okay, so how to find this probability? Just replacekan y equal to 0 dalam PDF function kita ni. Alright, so you will get 0.368. Okay, lagi dia kata, what is the probability that it will be visited once? Kalau visit once, macam mana pula dia punya, what is the probability? So we can find the probability of y equal to 1. Then replace y with 1. Then we will get this value. How about if it is twice? So maksudnya when y equal to 2. And then how about the probability that the officer will visit the location at least once. At least once maksudnya more than or equal to 1. Okay, so means that you need to find the probability of y equal to 1, y equal to 2 until infinity. Tapi tak tahu berapa infinity kan, sampai berapa. So we can do this 1 minus probability of y equal to 0. Sebab kita nak probability of y more than or equal to 1 and above. So 1 minus dengan 0 and below. So 0 sajalah. Okay. So we'll get this. Another way is we can use the table. Okay, Poisson table. Nak cari nilai probability. If you use the red statistical table, that table is the table for give the probability that R or more. Maksudnya value probability dalam table you tu adalah value untuk R or more, greater and equal. So let's say kalau nak cari this probability, boleh terus ambil sajalah, tak perlu nak buat adjustment. Okay, so dalam you punya table Poisson ni, what we need adalah we need the value of average ataupun nilai lambda. Okay, let's see this example, lambdanya 1. Okay, lambda 1, let's say kita nak cari probability of y more than or equal to 1. So ambil R1, so the value nya adalah, kalau guna table ni, the value nya 0.6321. Okay, tak perlu tengok, tak perlu nak calculate manually, boleh terus tengok table saja. What we need is the value of lambda. Okay, that one kalau y more than or equal to 1, boleh terus tengok table. Let's say kalau nak cari probability of y less than 3 contohnya. Okay, kalau nak kira manually, you need to find the probability of y equal to 0, y equal to 1 and y equal to 2. Kalau nak kira manually. So you boleh calculate manually lah, just replace y 0, 1 and 2 in the PDF. Kan? If you want to use the table, kena buat adjustment kat sini, kena jadikan dia more than equal. So how to do this? Kita boleh buat adjustment. It will be apa yang kita nak adalah probability of y less than 3. Maksudnya 2 and below. Kita nak 2 and below. So we need to minus total of the probability, which is 1, minus dengan probability of y more than or equal to 3. Right? So kita tolak 3 and above. Sebab yang kita nak nilai probability 2 and below. Right? So kat sini boleh terus tengok table. Yang ni boleh tengok table sebab more than equal. Okay? So kalau more than equal kat sini, let's see kita punya lambda is 1, R is 3, 0.0803. Okay, try to find the value using your Poisson table. Make sure you know how to use the table. So 0.9197. Okay, alright. So ada dua cara lah. Two method, whether you find the probability use manually, calculate manually, or you can use the statistical table. Let's say I create another question. Okay, another question. Let's say find the probability that the officer visit the location twice in during an hour period of time. Okay, so here kita punya period of time-nya adalah an hour. Tadi half an hour. So we cannot use lambda 1 anymore. Tak boleh gunakan lambda 1 sebab lambda 1 adalah average untuk half an hour. Once per time. So the average now will be 1 for a half an hour period. So kalau an hour, so it will be, we need to multiply by 2. So the lambda will be 2. Okay. So to find nilai probability, we need to use lambda 2. So the PDF-nya sekarang adalah, the new PDF-nya will be 2 power of y e power of negative 2 over 2 factorial for y 0 until infinity. So nak cari the probability of y equal to 2, we need to use this PDF instead of the first one tadi, because of here the period of time dekat sini berubah. Okay, so for Poisson ni, first kena tengok dulu dia punya interval of time-nya dan juga nilai average parameternya berapa. Okay, before you start to calculate the probability. Alright. Okay. Okay, next adalah tadi you need to hafal ataupun memorize the PDF for Poisson. Okay, and then which is lambda power of y, e power of negative lambda divide dengan y factorial for y from 0 until infinity. Kena ingat dia punya PDF. Parameter untuk Poisson adalah lambda, which is the average. And then you also, before this, you also have memorized the value of mean dan variance for Poisson, which is lambda, which is its average. Average dengan variance untuk Poisson ni sama, which is the value of average, which is lambda. Okay, so you kena hafal that one. Another one yang you kena hafal adalah MGF, kan? Remember? Dulu you kena hafal juga MGF. So now kita tengok macam mana nak derive. How to derive. Macam mana nak dapatkan mean untuk Poisson ni adalah lambda dan variance for Poisson ni adalah lambda. Okay, we use the concept of mathematical expectation, which is the expected of y. The konsepnya adalah summation of y py. Okay, py ni adalah PDF of y. Okay, so it is summation of y multiply a PDF for y. This is py ataupun fy. PDF untuk Poisson multiply dengan y, summation of that. Okay, so kalau tengok summation ni from 0 until infinity, because our possible value for y tadi adalah from 0 to infinity untuk Poisson distribution. Okay, so what to do next? So dia kata the first term in this sum is equal to 0. Sebab the first part kan, the first partnya adalah bila y equal to 0, so y0 multiply dengan lambda power of 0 e negative lambda over y factorial. Anything plus dengan multiply dengan 0 will be 0. Sebab itulah kat sini dia start dengan 1. Y lambda y e negative lambda over y factorial. Okay, and then kenapa kat sini y minus 1 ni? Okay, saya buat yang lain. Okay, so expected of y tadi, saya start daripada sini. Here, this part start daripada sini. Start dengan 1 tu. Sebab tadi we know that the first term when we replace y with 0, so the value is 0. So kita start dengan 1 kat sini. Okay, y multiply dengan function of Poisson. Multiply dengan lambda power of y e negative y divide dengan y factorial. Okay, so now kita nak jadikan y minus 1 sebagai z. So kena jadikan dalam function ni ada y minus 1. So kita adjust dia jadi y okay, macam ni lambda y minus 1 lambda power of 1 multiply dengan lambda y minus 1, dia akan dapat lambda y. Kan? E power of negative y divide dengan y minus 1 factorial. So, remember, y factorial, kita boleh expand dia jadi y multiply dengan y minus 1 factorial. Kalau nak expand lagi, dia boleh jadi y multiply y minus 1 multiply y minus 2 factorial. Okay? So, we can eliminate this. So, ini akan jadi this part. Saya keluarkan lambda ya. Tinggal lambda yang ni saja di sini. Sorry, this is not, silap kan? Here is not negative y. Negative lambda. Okay. Right, so kita nak replacekan y minus 1 with z. Okay, bila nak tukar kepada z, this part pun kena tukar kepada z. So, bila y equal to 1, z will be 0. Okay, bila y equal to infinity, z still infinity. Okay, lambda power of z e negative lambda over z factorial. Okay. So, this part, dah boleh nampak tak? This part, okay, this part adalah equal to 1. Kenapa? Because of z adalah compare. So, bila you compare, z ni actually adalah Poisson, kan? Function of Poisson with parameter lambda. So, bila kita totalkan probability of z ni, totalkan function of z ni, it will be 1. So, because of that, here kita dapat lambda multiply by 1. So, aspect factor of y adalah lambda. Dapatlah that part. Okay, so dapatlah that part. Aspect factor of y equal to lambda. Okay, the next one. Macam mana nak dapatkan variance of, how to prove that the variance of y adalah lambda. So as we know, to find the variance of y, we can use the formula yang biasa itulah, which is aspect factor of y square minus dengan mean square. Okay, mean tak ada masalah. Kita tahu mean ni adalah lambda. Okay, so kat sini lambda square. So, kita kena cari aspect factor of y square. So, nak cari aspect factor of y square ni, kita tak boleh dapatkan in terms of y factorial, y square factorial. So, kena adjust sikit. Kita dapatkan aspect factor of y square daripada this expected value, which is it is aspect factor of y square minus dengan aspect factor of y. Kan? So, kita nak dapatkan aspect factor of y square here, which is aspect factor of y minus 1 plus expected of y. Yang ni yang kita boleh cari. Okay, so how to do this? Gunakan mathematical expectation. It is summation of, macam biasalah, y minus 1 multiply dengan by, which is the function of Poisson. Okay, so it is y minus 1 function of Poisson. Tadi expected, multiply dengan lambda of y multiply e power of negative lambda divide dengan y factorial y from 0 until infinity. Okay. Okay. And then bila you gantikan when y equal to 0 and y equal to 1, the sum will be 0, which is bila kita replacekan this part with 0, so all of this will be 0. Bila kita replacekan pula y here with 1, tapi di sini bila kita replacekan y with 1, so this part will be 0. So anything multiply with 0 will be 0. Faham tak? So actually boleh tulis macam ni lah. Kalau tulis okay, will be the part of 0 ni plus 1 minus 1 lambda 1e negative 1 divide dengan 1 factorial plus yang lain-lain tu kita start dengan 1 dekat sini. 2 infinity y minus 1 multiply dengan lambda y negative lambda divide dengan y factorial. This two part is 0. Okay, this two part 0, this part also 0. Okay, so what to do next adalah kita nak jadikan z y minus 2 as z. Kenapa nak ambil y minus 2? Sebab sini y equal to 2. Okay, so apa yang perlu kita buat? Kita kena expand lah. Kena jadikan dalam function tu ada y minus 2. So what to do? Sini kita boleh buat lambda square multiply dengan lambda power of y minus 2. So dia akan dapat lambda y di situ kan. So kat sini multiply e negative lambda divide dengan y multiply y minus 1 multiply y minus 2 factorial. Okay, so I sambung dekat sini. So here kita boleh eliminatekan y minus 1. Right, so apa yang tinggal dekat sini, lambda square multiply dengan summation y to infinity lambda y minus 2 e negative lambda divide dengan y minus 2 factorial. And then we replace y minus 2 tu dengan z. So it will be expected of y y minus 1 equal to lambda square. Okay, replacekan y minus 2 dengan z. So, bila y equal to 2, z will be 0. Until infinity. Bila y equal to infinity, z will be infinity. So, this part, kita gantikan y minus 2 dengan z. Z factorial. Okay. So, macam tadilah, this part ni adalah 1. Equal to 1. Because of z adalah Poisson with parameter lambda. So, summation of the Pz equal to 1. So, aspect of y minus 1 adalah lambda square. So, bolehlah kita gunakan this part. Tadi dah tahu dah aspect of y minus 1 ni adalah lambda square. Kan? So, it will be lambda square plus lambda. So, aspect of y square adalah lambda square plus lambda. So, from here, we can find the variance. Lambda square plus lambda untuk aspect of y square. Okay, minus dengan mean square, which is lambda square. So, the value of variance will be lambda. Okay, so you boleh buat secara teratur lah. Okay, the step. Okay, this is the method. The way how we prove that the variance and the mean for random variable y ataupun when y adalah Poisson, okay, the mean and the variance is the value of average, which is lambda, the parameter dia lambda. Okay, so that's all to Poisson. If you have any confused kat mana-mana, you can directly ask, okay, as soon as possible. Alright, thank you.